Here's one more example so you don't start to think that the shape of every cross-section is a square. In this problem, we have a region R, and it's going to be the base of a solid. Here they tell us there's two big changes. The cross-section taken perpendicular to the y-axis. So we're going to take our slices perpendicular to the y-axis. And they have the shape of a rectangle. So this is going to be a slightly different way that we're going to have to find area, right? We have an area that's a rectangle, shape that's a rectangle. Okay, so a couple big changes. Here we've been told if we need to take slices perpendicular to the y-axis. That means that I'm going to have to integrate with respect to y, which means the limits on my integral are going to be y limits. So I'm integrating essentially from bottom to top. So my lowest y in this picture is 0. My highest up y is 6. And no matter what I do, I'm going to need my function, my area function, which is going to go here in this big blank spot that I left. I'm going to need that to be a function of y. So my first step is going to be to take my boundary function and solve it for x. So y equals 2 square root of x. I'm going to divide both sides by 2. I would get y over 2 equals square root of x. I'm trying to isolate x, so my next step would be to square both sides, and I would get y squared over 4 equals x. So that's going to be important to me because one of the dimensions I need for finding the area of a rectangle is that length across that slice that I just took. So I just drew it in blue. And notice that distance x. If x is the length of a horizontal line segment, I find the length by subtracting the x-coordinates of the two endpoints here. So I'm subtracting the x-coordinates, but I need those x-coordinates to be written as a function of y. So what do I need to know? I have it written up on the next slide here. To find the area of a rectangle, I'm going to multiply this length times the height. And they've given us some information about the height. They said that the height is 3 times the length. So I know going in that, well, I know a couple things. I know area is going to equal length times height. And I know that height happens to equal 3 times the length. So I'll write it up on the next slide. Here we go. I'm going to need to integrate from 0 to 6. I'm integrating with respect to y this time, of the area of one rectangle face times the thickness of the rectangle, which is this dy. 0 and 6 are the y limits, so I know that area for a rectangle is going to be length times height. The length is the distance in the of that horizontal line segment that I drew in blue on that last picture. And I've been told, it was nice that they told us, because otherwise I wouldn't have been able to figure it out, that in this case, the height is equal to 3 times the length. So you can see I've replaced h with 3l. Now you wouldn't necessarily need to show all these steps. I'm just showing you my thought process as I walk through this problem. So I could just rearrange that. I could bring the L out, the 3 out to the front, and then I'm going to have L times L as my integrand, so I'm going to call that L squared. And notice here that I do have an expression now for the length of that horizontal line segment. It's always going to be y squared over 4. So my final answer, 3 times the integral from 0 to 6 of y squared over 4, all squared dy.